Hello everybody, my name is Davide Francisci and here is a student Aitor from Spain, and we are going today to make a little demonstration on how we use microplates for the screening of microalgae in wastewaters. So first I'm going to show you what we have here. Here we have some cultures of different strains. One is Microplate, one is Microplate magnetica, one is the Micrococcus pluvialis, and one is Senedesmus obliquus. Each of these strains have a specific high added value that can be used for biorefinery. So for example, Microplate magnetica has a high content in lipids, and Micrococcus pluvialis has a very important pigment called astaxanthin, which has a very high value on the market. So here we have wastewaters coming from Estonia, and here we have many different other ones. So we are going to show how we use these microplates in order to test different conditions in very small volumes. Stop. The advantage of using microplates is that we have, in this case, 24 wells. So at the same, each well has a volume of 2 mils. We have actually other microplates that contain 96 wells and other with only 6. These microplates with 2 mils for a total of 24 is a good compromise between the number of conditions that can be tested and the volume. And the good advantage that this gives is that in this way we can, at the same time, using a number of other equipment we are going to show later, we have the possibility to compare at the same time the growth happening in the different wells. So, as I said before, we have a number of species and a number of wastewaters. We could imagine a scenario in which we have a specific wastewaters and we have 10 strains and we want to know which one is the best for growing in this wastewater. We can have several wastewater and we want to know which one is the best for a specific strain of microalgae, and eventually we can imagine a scenario in which we can mix different wastewater because some of them have a certain amount of nutrients and that are complementary to another wastewaters, and we want to find the best combination. Of course, you can imagine that such an experiment done even in flasks would require a lot of space and a lot of time, while in this case, at the same time, we can perform this analysis in a very short time and in parallel, so we can have a real comparison between the different conditions. So what we are going now is make a demonstration in which we have all different wastewaters, and we have one strain that is very well known in biotechnology, is Chlorella sorokiniana, because it's very robust, it grows very fast, and is able to grow in many different wastewaters. And so we are going to try to screen different wastewaters against these species. Once we have placed the volume inoculated the algae with the different wastewaters intricated in this microplate, we are going to apply a breakable membrane, and then we are going to incubate this microplate on this LED light, so that we have, and of course this will be placed on a shaking table. So in this way, each well will receive the very same amount of light to have a very good comparison between this growth rate. And this is also the reason why the microplate is black. So you cannot have that, you have light coming from other sources, and so there will be a difference between the wells in the middle and the wells at the side. Stop. are now rotating the microplate to be sure that the breathable membrane was placed properly and that there is no leaking of liquid from the microplate. Once the microplate has been prepared and the first measurements at, let's say, time 0 has been done through the Synergy microplate reader, now the microplate will be placed on the LED light, which, as we have stated, is made in a way that there are 24 lights that are identical. And at this point it is incubated on an orbital shaker for a certain period of time. Measurements will be taken different times a day in order to follow the growth of the microalgae, always with the Synergy microplate reader. Stop. Okay, so now we're doing this blah 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 blah. So we keep doing this blah 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 blah.